Everyone, welcome to the second part video on the product and the quotient rule. Just as a reminder, if you want to follow along with this video, you should have a note sheet called 2.4 Notes, Product and Quotient Rule. And we are just continuing from the previous page. This was the end of the last video, examples of product rule, I should say. So the second half of this is talking about the quotient rule. So we now know how to take a derivative of a product of two factors of different functions. Now we want to look at the quotient. So looking at this example here, we can actually prove the quotient rule by using the product rule. And so this example is just giving you an example of that for you to follow along. Using left d right plus right d left, you would take derivative of the left, leave the right alone, plus, I should say, left times derivative of the right. And as you can see here, as we're going through the remainder of this, cleaning it up, using the derivative of g to the -1 is -1g to the -2nd, and moving some things around, getting common denominator, we create this right here. So the quotient rule is just an algebraic manipulation of the product rule. And so it looks a little different because we are dealing with, as you can see here, this g to the -1st, which sort of changes some things up with what we're doing. So how do we remember this? When given two functions that are being divided by each other, that is f of x being divided by g of x, what we are going to say is to find the derivative of it, we're going to take the low denominator term, multiply it by the derivative of the numerator. Then we're going to subtract from the numerator times the derivative of the denominator, and that is all going to be divided by the original denominator squared. Not the easiest rule in the world to remember, so I have a couple tips and tricks here to help you remember this. This is what I personally use myself to help me remember the quotient rule. I consider the denominator the low term of the fraction. I consider the numerator the high term of the fraction. And so using that idea, I say we take low d as in derivative, low d high, minus high times derivative of low, all divided by low squared. So you might sound like a yodeler when you say this, but it's going to help you remember this. Low d high minus high d low over low squared. This is how I remember it. If you say this enough times, it kind of becomes like what the quadratic formula was to you in Algebra 2. You learn it, you find it to either a tune of a song or kind of a rhythm as you're saying it to yourself, and it helps you remember it when working through problems. So low d high minus high d low over low squared. Now that you know that, let's look through a couple examples that is, of how we use this. The first two examples are going to be the same examples from video number 1. Let's go back all the way up here and show you. Video number 1, letter C and letter D. So in both of these examples, we're able to use the power rule as long as we simplified the expression first. And I say this again, these two, I would still use the power rule once you know the quotient rule, because guess what? Power rule is much easier, and doing a couple little algebraic simplifications pre-derivative are always going to help you in the long run. With that being said, we're going to look and do this with the quotient rule, just to again prove the point that either rule would work. Here we go. We have our low term, which is 4x cubed. We have our high term, which is 8x to the 7th. And so our derivative is going to be low d high. So that's going to be 8 times 7, so 56x to the 6th, minus high d low. So, and that's all divided by a long fraction bar here, low squared. Now, keep in mind, it's not just lows, it's the entire quantity squared. And you're going to see how that's important here in just a moment. So we go ahead and we do some simplifying here, okay? So we're going to get 4 times 56, so that should be, let's see, that's 224, I believe. X to the, now when you're taking these, you add them up, so that's 9, minus, you're going to have 8 times 12, 96, x to the 9th, divided by 4 squared is 16, 3 times 2 is 6, and so we can just do a little bit more simplifying. And again, the question from the last video, how much should I simplify? This is reasonable. This is just combining like terms, so this should be an expectation definitely when you're doing this. The other rule of general is no complex fractions, no negative decimal or no negative exponents, that is. 128 divided by 16, I'm sorry, is 8x to the third. And if you recall, 8x to the third, our final answer is from the warm-up in the first video, exactly what we got. So this confirms that the quotient rule and the power rule both would work for this first example. Take a look at another one. Okay, in this case, once again, it's good to identify low and then your high term. So let's go ahead and let's walk through it. So low, d high, so this is x to the 1/2. So this is going to be 1/2 x to the negative 1/2. So low d high minus, remember the 5 is just a 0. Derivative of a constant is always 0. High, I'm going to leave it as 1/2 for right now, just until we get things dealt with. D low, which is just a 1. I do not need to write that over low squared. So once again, we're going to do a little bit of simplifying here. We're going to get a 1/2. We're going to get an x to the 1/2 because this is a 1 plus a half. Minus, now remember this minus sign right here, you need to distribute that to the entire second half of this. So low d high minus the quantity of high d low. So this is important that we distribute this out. So this is going to be x to the 1/2 plus 5 over x squared. Okay. So as we simplify that, we're going to get x minus, because these are going to be like terms, these right here above. Okay, these are like terms. 1/2 minus 1 is going to be in minus 1/2 x to the 1/2 plus 5 over x squared. Now in situations like this, remember I said no complex fractions, I think the best way to handle this would be take that denominator. Remember that dividing by a number is the same as multiplying by its reciprocal. So if we do that, we are now able to take this times 1 over x squared, and we can end up with our final answer here. So this is going to be x to the negative second, remember. So this is going to be x to the 3/2 down at the bottom. And there should be a 2 there as well. Plus 5 over x squared. And so this is going to be our final answer for the derivative. So a little bit more simplifying has to be done with these. It makes it a little bit more annoying, but nonetheless, we should be getting the same results we got before. Here are 2 more additional examples I'd like you to try. If these aren't in your notes already, go ahead and write them off to the side here, just to the right-hand side of our problems that we just did. Take a moment, pause this video, and try to use the quotient rule in both of these examples to take the derivatives. Once you have an answer, press play, and I will have solutions on here for you. Okay, here are the solutions to the last 2 problems, and just a couple notes I'm going to give you. So for the first one, you have exponential and a trig in here. There's not really much to do to simplify, at least in the initial start of this after you take the derivative. But as you can see over here in my solution, I left the final answer like this as one unified fraction. But you also could use trig identities to try to simplify this further. Sometimes this is going to make it look a lot better, sometimes it doesn't. In this case, I used trig identities. I had sine over sine squared, so that's going to cancel a sine, leaving you with cosecant. You have cosine over sine squared, which can simplify to cosine over sine, which is cotangent, and then you have a leftover 1 over sine, which is cosecant. Then if you factor that all out, you can create a solution that looks like this. Depending on, again, down the road when we start doing applications of this, when you have to find horizontal tangent lines or other different applications of that, maybe you like the version on the left, maybe you'd want to use the version on the right. The moral of this is that you can simplify to whatever needs you have when you're doing problems in the future. For the last example, this is another great example of don't go crazy with simplifying because sometimes it's going to be a waste. In the denominator, you have x squared minus 3 quantity squared. And if you go ahead and you FOIL that out, great, but it's not going to actually do anything to help you simplify the problem at all. So in this case, I left that just as a quantity and I just simplified the numerator, combining my like terms, and I got perfectly good answer here that I would be able to use for problems down the road. So that concludes this video on the quotient rule. Be sure to check out the lesson plan for additional practice problems and things to try. And there will be a final 3rd part video which talks about how we can find the remaining 4 trig function derivatives, and a little hint is going to use the quotient rule to help you with that.